Explain it in complete sense. Then the next inverted triangle, we are going to use it with x and x. Again, notice that it is applied on a vector function. Google a vector function, it's very necessary. Then you have a curl, that is when you have a cross product of something, you get a direction, right? If you are having two things like x and y, and if you apply x cross y, you get something in direction of my thumb, that is in direction of z. So that is what a curl is. You are curling things, right? Again, since it has got direction, it is applied on vector. So these are the things that we are going to worry about and learn about. So let's get started. We will see all these three kinds of function, and then we will see what kind of operators are applied on them. So let's get started with our first one. Our first example is f of x depending upon only one variable. So in this case, we are going to find, since it depends on one variable, we are going to find d by dx. Okay, so when you differentiate it, please, if you don't know differentiation, go for it, look on Google or books. So when you differentiate it, we get 2x plus 1, right? Now, can we find dou by dx for that? Because we saw that this is used when things depends on two variables or more variables. Can we go for it with this? Of course we can. Because why? We don't have any other variable y. So it's alright. It will act as just like this. It actually acts just like this. The only reason that we use this notation is to tell that the function is depending on more than one variable. So you can write it either way. Just we have decided it according to the norms. Okay, so it will be the same either way. Now let's say if we have a function depending on two variables. So for this, what we use is dou by dx and dou by dou y. Like dou by dx will be like y is kept constant and x is differentiated, so we get 2x. When you gotta find dou by dou y, you gotta say x square is constant and you differentiate this term, so you get 2y. So it has got nothing to do very much with methods of differentiation. It's just like you guys representing it in a way so that you understand that it depends on two variables. That is why you are using this notation instead of this notation. Okay, let's make things more complicated. We gotta get an inverted triangle that is called an something depending upon operator, that is derivative. It is like a derivative, but it has got direction involved in it. Like you gotta differentiate it with respect to x, y and z, but you have got direction associated. So that is all about NEBLA. So far we have seen that dou by dx and dou by dy, they can be applied on scalar as well as vector. So can this function, I'm sorry, it's not a function, it's kind of like a tool. Can this tool be applied on a scalar or vector? Yes, it can be applied on scalar, it can be applied on vector. Scalar means f of xy equals x square plus y square, and a vector field means, pardon my handwriting please, x square y x cap plus y square y cap. It can be applied on both kind of things, with direction and without direction. So when you have it on a scalar field that is without direction, what is the term used is gradient, like this. It's just a normal multiplication. You just multiply this whole lot with whatever function like this you have. So if you have this function, just multiply it. So you multiply this whole unit with this, then this whole unit with this. Then you have differentiation of it. You got, when you differentiate it with respect to x, you get 2x and the direction remains as it is. Then you differentiate it with respect to y and the direction remains as it is. So in this case, what you get is a vector. Remember, this was a scalar quantity, then you applied a gradient on it, that is a normal scalar product, and you got a vector quantity. This is called gradient, and it represents in which direction you got to move so that you can have maximum value of a function. I'll advise you to Google it.